Our next technical session discusses the security functions and services for embedded platforms to achieve right security assurance levels. It is presented by Mr. Vinay Thapliyal, Technical Marketing Manager, MCU India, STMicroelectronics, India.
Hello everyone, I am Vinay Thapliyal, in charge of MCU Marketing and Applications at STMicroelectronics, India. Today, I am going to talk on a topic, security functions and services for embedded platforms to achieve right security assurance levels. So in this session, you will learn about the various security threats and countermeasures, different security assurance levels, and security functions and services. We also will talk about some practical examples which might help you to connect with your applications. Before starting, let me brief you about ST Microelectronics. ST Microelectronics is one of the world's largest semiconductor companies with last year revenue of $12.8 billion. We are spread across globe with over 80 sales and marketing offices and have 48,000 employees with 13 own manufacturing sites. ST stands for Life Augmented. ST vision is everywhere microelectronics makes a positive contribution to people's lives, ST is there. So to start, as we most know why security matters, security is about protecting assets. Some of examples of these assets are consumers' private information like finance, health, passwords, etc., services, IP, firmware of a product or solution, health and safety, or at workplace like production equipment, access controls. Damage to an asset may affect the normal operation of the system, including denial of the services, as well as that of individuals and organizations involved with the system. Let's consider few threats and their consequences. First, the threat on device cloning and counterfeiting. Its consequences could be compromising OEM devices and revenues of service providers. It can lead to data breaches and loss of privacy, can cause service quality issues and potential denial of services. Second threat of data corruption can lead to misinterpretation at service level, can damage service quality and reputation, or can impact end user safety as well. The other threat of data breaches can expose private and user data, impacting people's lives. Stolen data can impact the service providers' liability and reputation. So to counter these threats, we rely on various functional countermeasures like data, identity protection, secure storage, secure communication, authentication, secure boot, firmware upgrades, etc. Further, protecting the assets ensures confidentiality, integrity, and availability of data. So what we mean by these terms? Confidentiality. Information is only made available to authorized entities, and information is fully protected from unauthorized requests. Integrity. Data accuracy and completeness are maintained over the life cycle, and data cannot be modified in an unauthorized manner. And availability. Information is made available to authorized requesters only whenever needed. So as we discussed, protections mitigate vulnerabilities and therefore can mitigate these threats. Security functions and services are great measures to mitigate these risks. As a designer, you must identify assets, threats, and such vulnerabilities to define protection strategies and countermeasures that reduce risk to an acceptable level. So if consider an embedded design, a complete security framework can be prepared with following steps. Number one, identify threats according to different types of customer assets. Two, propose mitigation strategies via security functions and services. And third, rely on recognized security assurance levels. The goal is to help customers protect their assets and reach the required security assurance levels. So what we mean by security assurance levels? A security assurance is the confidence that a system meets its security requirements and is resilient against security vulnerabilities and these failures. The confidence indicated by different security assurance levels represents the level of trust we can give to a system that is safe to be used. Let me take example of one of such security framework which is prepared by ST. It is called STM32 Trust. Within the maze of various applications using MCUs and MPU, STM32 Trust focuses on four main categories, category assets that are data, IP, connectivity, and system trust. These represent the vast majority of assets we could encounter on the market and covers pretty well other assets with close functionalities and protection requirements. Data will address all around protection, confidentiality, privacy, integrity, secret storage, and authenticity. IP concerns all aspects about intellectual property, such as software codes and binaries, data, manufacturing secrets, and processes. Connectivity, as many objects will be required to be connected, a special focus is done here on all protections required for IoT devices. Beside the communication on and authentication, data privacy, integrity, and authenticity, denial of services within a growing ecosystem of national or at corporate regulations. System trust. This embeds all around building trustable devices in a world of regulations, improving reliability, often guaranteed via software updates, concerns around availability or denial of services, authentication to ensure the device authenticity will represent important concerns from our customers. Let's explore which security assurance levels and certifications are followed by such security framework. At device level, STM32 Trust focuses on two product certification schemes, SISIP and PSA. We will discuss about these certification schemes in details in next slide. It makes device compliant with multiple national security standards, meeting security requirements of most applications. Below, you can see some of such popular standards like FIPS, PCI, Common Criteria, IC, etc. As indicated earlier, the product security assurance few most acceptable standards for IoT platform has been SISIP and PSA. SISIP stands for Security Evaluation Standard for IoT platforms. It is published by global platform to align protection profiles to multiple security assurance schemes. It provides a common and optimized approach for evaluating the security of connected products that meets the specific compliance, security, and scalability challenges of the evolving IoT ecosystem. The other popular platform is PSA, Platform Security Assurance by ARM. It also focuses on protecting these IoT devices. Further, a highly enhanced level of standard has been Common Criteria L5 Plus. This is enhanced security with the highest hardware resistance based on secure elements, which can be connected along with an MCU. STM32 Trust is based on these accepted security assurance schemes with SISIP and PSA to ensure customers build confidence in product implementations, allow customer reach of most of the market security requirement schemes. So let's see some building blocks of security of an embedded system. From left side, crypto engine. These are basic crypto services embedded in a dedicated chipsets, computer firmware, pure software countermeasures against remote software attacks mainly. It's self-evaluated solutions. Third, MCU and MPU with embedded security. You should consider a broad MCU platform which can offer features like countermeasures against remote software and board level attacks, should have STM32 Trust like security framework, possibility to use trust zone architecture, which is coming from ARM, assurance levels like SISIP and PSA certifications, and secure programming services. For further enhanced security, you can have secure companion chip like ST Secure. It is a trusted component that can provide tamper resistance at hardware and SoC level, common criteria, GSMA like certifications, proven against all attacks, maybe remote software, board level, and at silicon level attacks. So let's check the certification status at product levels. PSA provides three levels from level 1, which is basic self assessment, to level 3, which provides compliance up to physical level attacks. CISIP provides 5 levels from self assessment up to smart card like L4 plus. Its level 3 is at par with PSA level 3. Different MCU platforms manufacturers comply with these different levels of implementation. Some could be at silicon level and some at software level. Here you can see on right side the STM32U5, which is one of the latest product from ST. It provides CISIP and PSA level 3 compliance with the help of silicon implemented features plus TFM software framework module, which is coming from ARM. Higher security compliances like common criteria, L5 plus, also possible with the addition of ST secure devices, as we discussed in earlier slide. Let's see some practical examples which you can also try to correlate with your application use cases. So we have taken some customer examples. The first example we have taken is to focus on secure manufacturing. So here the asset is product. For example, Bob is at the head of a company designing toys. So he would like to avoid the counterfeiting of his company branded toys. So what Bob needs to achieve? Firmware protection during production management at manufacture, not having the overproduction or underproduction, protection against the programming of other devices during this production, firmware protection in the field. So to achieve this, he can use some of the security functions like IP protection. For example, secure manufacturing, secure IP protection, secure installation and updates, silicon device complete life cycle. So these are some of the things he can ensure with the help of security function that his company is able to avoid the counterfeiting of the branded toys. Second example I have taken is on the focus on isolation and IP protection. So it means the asset is here IP. So for example, John is the company owner that is selling firmware. The firmware package features additional options that can be enabled by the user. So what John needs to achieve? He will need firmware protection, ensure the firmware package that is isolated from the customer firmware, ensure independent firmware updates, set application in a macro state while ensuring it cannot be altered. So the required security functions would be software IP protection, code isolation, again the IP protection kind of features like secure install and updates, and application life cycles. So let's take one more example, which is focusing on secure maintenance and updates. That also is very important nowadays in industry. So here the asset is product trustability. So Mark's company sells costly equipment. He plans to offer remote maintenance and updates. He wants to ensure that the remote updates are only performed on the equipment sold by his company and that only his firmware pack runs on the device. So what Marks want to achieve? Ensure only his equipment benefits from the remote updates. It's not that all the equipment should be updated. Access to information on product state. Ensure the firmware update is carried out in a very secured way, and firmware authentication and integrity of the software. So security functions requirement would be, one of them would be secured connectivity. So like through this identification, authentication, attestation, secure install and updates, secure boot and memory protection through system integrity checks. So these are some of the requirement he should have. Let's take one more example, which is focusing on data management. So here the asset is company data. So let's see one the person Oliver who sells devices that report sensitive data to servers. Oliver needs to make sure the data cannot be exposed outside his company. So what Oliver needs to achieve? He has to ensure the data transmitted is not exposed, secrecy in data encryption keys, ensure data is sent from authenticated devices, and ensure data is sent to authenticated servers. And the required security functions can be from data, crypto engine, secure storage, and from connectivity side to ensure identification, authentication, and proper attestation. Let's see one more example, which is focusing on remote access and control. So here the asset would be device integrity. So Rose controls her device fleet remotely. She wants to make sure her devices have not been hacked and have full control over the devices at any time. So what she wants to achieve: unique identity for each device, device authentication, attest device access rights, secure device communication, ensure that identities and access rights cannot be hacked even at the manufacturing stage. So some of the security functions she would need is on the secured connectivity, like identification, authentication, attestation, crypto engine, at data storage, secure data storage, and secured manufacturing, which can also include secure personalization. And one more final example, which is focusing on data protection. So here the data asset is data. So Jack collects and stores user data in his devices. Jack's devices and large-scale system need to be comply with regulations such as GDPR. So what Jack want to achieve? Platform integrity, integrity of user data, and secure storage of user data. And the required security function would be at system integrity level, secure boot, abnormal situation handling, secure connectivity like crypto engine, identification, authentication, attestation, and at secure storage level, secure storage. So you've seen some different examples, and I'm sure you will be able to connect them somewhere with your application. These are some simple use cases we have taken, but you can connect it with your application, and probably you can see more and more advantages and more and more connection with your security functions, what should be used. So let's see what is the offering from ST side. We already discussed in previous slides about STM32 Trust. Security has many layers and multiple levels. We saw its implementation depends on various factors such as product capabilities, the application requirements, the security assurance level requirements. Therefore, STM32 Trust based its offer upon a set of scalable security functions. STM32 Trust simplifies the mitigation model, analysis with pre-analyzed threats and vulnerabilities, mitigation with ready-to-use security functions and services. So STM32 Trust is a security framework trying to leverage the experience of ST on security, lowering the reach of security for our customers. Most common assets were reviewed and went through a mitigation model analysis, looking at assets, threats, vulnerabilities, and proposing pre-validated and ready to certify security functions and services, allowing our customers reach their targeted security assurance levels. For simplicity, a summary of 12 security functions were defined and developed around STM32 products. These would be either embedded in our products or proposed as software add-on or services. So here you can find more details on each of these 12 security functions. 1. Secure boot, ability to ensure the authenticity and integrity of an embedded application. It ensures that the boot and OS software is the intended manufacturer version and has not been tampered with a malware or malicious third parties. Secure boot is applicable for any single use device. A good example is an e-reader, which is used by very popular processor. To secure installer updates, installation or updates of firmware with initial integrity and authenticity checks before programming and execution. So here lot of data, lot of applications require a lot of installations and updates over the firmware upgrade over the air. Third, secure storage, ability to securely store secrets like data and keys. It ensures that identities and access rights secrets cannot be leaked even at the manufacturing stage. Fourth, isolation. Isolation between trusted and non-trusted parts of an application. For example, a world of the application which is connected to the outside world, and one part of the application which is connected with the internal sensors. So both you can create a right isolation between these two worlds. Five, abnormal situation handling, ability to detect and to react to abnormal hardware and software situations. Crypto engine, ability to process cryptographic algorithm as recommended by security assurance schemes. Audit and log, keep trace of security events in an unchangeable way. Identification, authentication, attestation, a unique identification of a device and of or software, and ability to detect its authenticity. That every device shows a unique identity, authenticate single device, attest device access rights. Silicon device lifecycle, control states to securely protect silicon device assets through its lifecycle. 10. Software IP protection, ability to protect a section or the whole software package against external or internal reading. It can be multi-tenant. So for example, some of the IP protection which goes from a design house to the OEM, so they can do all the software IP protection. 11. Secure manufacturing, device provisioning or personalization in untrusted environment with overproduction control. No firmware stealing at production, no overproduction by manufacturer. Ensure firmware does not program devices not owned by the company. And 12th, application lifecycle. Define unchangeable incremental states to securely protect application states and assets. So I'll now conclude with some key points to summarize this topic. A security framework with defined security functions and services like STM32 Trust security ecosystem is of great help to implement security in your new product designs. Starting from customer use cases and security needs, we have defined a set of 12 core security functions, which are the foundation to fulfill all the common security needs. For ST, these functions are implemented and supported across our product portfolio using our MCUs, STM32, and potentially our ST safe secure elements. And we also provide reference packages for seamless implementation of a secure boot or secure firmware updates. And finally, we have evaluated and certified our hardware platforms in combination with the reference software packages according to new security standards, being the first one on the market certified with PSA level 3 and CZIP level 3, so that at the end of the day, the customers really trust the deliveries to secure their products. You can go through below link www.st.com/stm32trust for more details. Thank you for being nice listener and audience.